your quadratics. Your quadratic falls in this, ax squared plus bx plus c, right? And you do this when you use a quadratic formula, you pull out your ABC, blah, blah, blah. We also have a standard form. It's called its vertex form, where h and k is the vertex of your quadratic. This is the vertex point. The vertex is the turning point, whether it's the minimum or the maximum. A, if it's positive, means it opens up. If it's negative, it means it opens down. It's the same thing that when you do this, negative x squared, there's your parabola opening down. Positive x squared, there's your parabola opening up, right? So there's certain things we're going to look at from here. Your x and your y are here. Your x and your y, they stay in your formula. F of x is the same as your y value. And this is where your x stays for your formula. So we're going to take this part, this quadratic, and put it into vertex form. To do that, we complete the square. Sometimes you're lucky, you have one that's already perfect square, but most of the time we're going to complete the square. Now we're going to start with a really, really simple one. And let's start with a simple one. Okay, I'm just going to keep that information there. So if you don't mind writing this down, we're going to take a simple one like this. Now, if we were to factor this guy, would I be able to get factors of 7 that add up to 4? No. So what kind of roots does this tell me it has? Irrational. Good. And to find that, I would have to use the quadratic formula to find their roots. Because when you want it in the exact measurement, it has to be in the radical form. You can find it in your calculator, but then you're estimating. It's not the exact value. Whenever we say exact value, lowest fraction, reduced radicals. So to take this, we have to either use our quadratic, and we really can't graph this by looking at it because we don't know the roots. We don't know where the axis of symmetry is. So to do this, we put this in vertex form. And when we put it in vertex form, we complete the square. So the first thing you want to do is group the x's together like this. You're going to group the x's. Work with me. This is the easiest way to do this. So we're going to go like this. Inside my parentheses, I'm going to leave a little space here to complete this part. My plus 7 stays, and whatever I add to one side of my equation, I also have to subtract, right? I have to keep it the same. So I'm subtracting it here. If I added it, I have to subtract it. And you might remember this part from last year. We took the middle term. This is the b. We took half of b. That helps us complete the square. So what is half of -4? So since it's a negative, we do x minus 2. We square it. Stay with me. Now we go like this. What is 2 squared? 4. Isn't this completing my square so that now I get x minus 2 as factors, which is x minus 2 squared, right? We made this become a perfect square. But I have an equation. So if I add something to my equation, I changed it. So if I add it, I'm going to also subtract the same value right here. So now if I add 4 and subtract 4, did I really change my equation? No. So I've got this part right here, and then I combine these terms. There's your vertex form of your quadratic. Now if I line this up to this, there's my A, x minus h squared plus k. We're going to pull out your vertex. Your vertex is h, k. If you line this up and go like this, you say negative 2 is equal to negative h. Therefore, what is h equal to? 2. So notice it's just like your horizontal translation, isn't it? Doesn't it go the opposite way? Your horizontal translation did that. Your circles do that. Your center comes out the opposite way. So if this is negative, it comes out positive. If it's positive, inside the parentheses only, it comes out negative. So our vertex will be 2, 3. That one stays the same. So if I was going to graph this, I now know that here's my vertex, 2, 3. And which way is my parabola opening? Up or down? Up. Why? Because it's positive. So I don't know how wide to make this thing. I'm not sure how wide. Is it narrow? Is it wide? So what helps me now is finding an intercept. And you've been finding intercepts, so that part's not new. So I have no x-intercepts, right? Because it's going to open up. I have no real x-intercepts. So it's opening up. So let's find the y-intercept. When I'm looking for this guy, what is the value of x? 0. So I come through my equation and watch what happens. See this equation? That's a 0, that's a 0, y is 7. This part blacks right out. So y is equal to 7. I just plug a 0 in here. 0 squared minus 4 times 0. There's my intercept right there. Y is equal to 7. So I know this point is 0, 7. So if this is 2, 3, 0, 7, I'm over here somewhere. Here's my parabola. I know it's symmetric. I know it's symmetric over my axis of symmetry. So if this point is 2, 3, what's this line that I just drew through here? What's the equation of that line? X equals 2. Your axis of symmetry is x equals whatever value this is, h, the part of our vertex, the x value of your vertex point, because it creates a vertical line. So we're able to do this. Now, if I use my x-intercepts, and you might have to show this to me algebraically, that they're not real, I substitute in my y. Normally, I would do this guy, right? And I would say quadratic formula. But I don't have to do that. Because we solved it like this, we're going to take this piece, and we're going to do this. X minus 2 squared plus 3 is equal to 0. I'm substituting my 0 into this one. From that equation, we solve for your roots. Subtract 3. Look how easy this is. This is what your quadratic equation does. And you get x minus 2 squared equals negative 3. How do you undo a square? Square root. When you square root a negative 3, in our real number world, can we take the square root of negative 3? So therefore, this shows us we have no real x-intercepts. They're imaginary. Okay? And it tells us because, oh, we had 2 roots. The highest exponent is 2. We should have had 2 roots. So if they're not real, they're imaginary. And we could take out the I, and we could do that, but for this purpose, we're only going to use our real roots. So once you've completed the square, that makes it very nice to find your roots. We'll do another one where we can actually find your roots. You don't have to go back to your original equation. Use your vertex form. Once you get used to doing this one, you'll probably never use your quadratic form again, because this is so much easier. And it tells you everything about your parabola.
When you found the y-intercept, it was x.
0, 7 here. So my parabola goes like this. It crosses this line at 0, 7. Right to 0, 7. Somewhere up here. This is 2, 3. So 7 would be a little higher, right? Not 7, 0, not your x-axis. This is 0, 7, your y-axis. Make sense? Okay? Questions? Questions?
So the roots, this is the 2 roots. So what are the 2 roots?
The roots are where it crosses the x-axis.
So they're imaginary.
They're imaginary. We don't have any real roots to this. Remember your roots or your solution? Your zeros. Your zeros were across where y is 0.
So would it ever ask like what are the roots when they're like?
And you would say, in this case, you would say imaginary. You would say no real roots. In the next one, we'll show them that they actually come through, and we'll figure those out. But you could have no real roots on this.
So the x-intercept is just to show that there was no.
Right, algebraically, we're showing that they didn't have any. And by our graph, can we tell by our graph?
Yeah.
Yeah, we can tell exactly by graph. So, did we ever pick up our calculator to do this? We didn't even pick up your calculator, and we graphed everything. Pretty sharp. Okay, let's try another one. This one, first this one gets a little bit tougher. All right. Before we take a look at this, what do you know about this graph? What can you tell me? It's a hard trinomial. It's hard. Okay. What can you tell me? Which way does it open? Up. Can we factor this? Well, let's try. 8 times c. What's 2 times 7? 14. Are there factors of 14 that add up to 8? No. So what kind of roots does this have? Irrational. Now normally you would put your quadratic here. But if you told me to graph this, I would say, I'm not really sure. I don't know where my roots are. I could figure out my vertex point. I could figure out the negative b over 2a. I could find my axis of symmetry. The old way we used to do it. Remember this way? Negative b over 2a. Find your x. This is your axis of symmetry. Then plug your x value in and find your y. Remember how we found your turning point back in the day? So we're not going to do that. We're going to complete the square. So gather up your x parts like this. And let's start like this. Keep it in parentheses. And make a space. Your 7 is out here. If we added something, we have to subtract something. Yep. We're going to add inside, and we're going to subtract on the outside of it. Yep, always. Always. Because whenever you square something, even if you square a negative, it becomes a positive. But the rest of it kind of works itself out. Now, we have a problem because a is 1. Jay didn't even want to factor this because she said, no, it's a hard trinomial. You're right. A has to be 1 before we can do this. And we don't like it if it's not 1. So, what do these two guys share? What can we take out? Not the x's. 2. So, leave the x's. We'll take out a 2. So, rewrite this like this. You still have the rest of it. And now let's inside your parentheses. That makes it easier to make a perfect square, right? So, we're going to use the rule half of b. What's half of 4? Positive 4.
2.
So go like this. X plus 2 squared. And I like to go like this. What is 2 squared?
4.
That goes right here. 4. Now, here's the problem. This guy's stuck inside this parentheses. In order for me to write him over there, I have to take him out of this parentheses. So I have to multiply 2 times 4. And what is 2 times 4? That goes over here. 8. So let's do the rest. Bring down this 2. That comes down. Y equals. And what is 7 minus 8? Negative 1. So here is our completed the square parabola. Let's see what we know about this. We know it opens up because you already told me it opens up. It was positive. What's my vertex? HK. This would be my H. This would be my K. but take it out the opposite way in the parentheses. -2, -1. What's my axis of symmetry? What x value is that line going to cut through? What x value is the vertex at? -2. So my axis of symmetry is x equals -2. I know this so far. So if I come over here, I could start with -2, -1. There I am. My parabola is opening up like this, but I'm not exactly sure if it's wide or narrow or where I am.
Where do you get the -2 from?
Inside here. Your formula is x minus h. Remember when we do the translations inside, they go the opposite way? Remember when we did our translations, they affected x, but they shifted the opposite way? Think of it this way. Take it out the opposite way. Because if I set this up like this, I have -h is equal to 2. To solve for h, I get h is -2.
So it goes the opposite.
Opposite. Take in the one inside the parentheses, it comes out the opposite way, not the one outside.
And so, you know, I could schedule enough work because it puts course and flat inside of the parentheses.
The 4's never cancel out inside, but I can't put 4 over here until I take it out of my parentheses. Before we had a 1 here. We didn't have any problems. So we just put 4, 4. But this guy says this is inside this parentheses. Multiply this first and then put it over there.
How do you know when to do that?
If you have any value outside of here.
Okay.
If you have a 1, it stays the same, right? If we factor anything out, we have to factor it back in. So let's find your y-intercept first. Come back to your original equation. Tell me what your y-intercept is from this one. 7, because isn't this 0, 0? So y is equal to 7. So I plug a 0 in here, and my y is equal to 7. So my y-intercept is 0, 7. Somewhere up here, right? So I can kind of figure out where I'm going. But I don't know if I'm crossing this side or not. So now we're going to find your x-intercepts. These are the roots or the zeros. So we are going to take this equation that we have and set it equal to 0. We're going to find it like this. We haven't picked up your calculator yet. We're going to add 1 to both sides because we got to get this by itself before we can take the square root of it. We're going to divide both sides by 2. How do you undo a square? Square root. We're going to square root. And when you square root, you get what? A plus or minus. And now all we have to do is solve for x. Subtract 2. So -2 plus or minus the square root of 1/2. These are your roots. So you're going to have x is equal to -2 plus radical 1/2, and x is equal to -2 minus radical 1/2. Now, those you can put in your calculator. That you can put in your calculator and figure that out. So let's see what that comes out to be. And let's judge where your root goes. Sometimes they come out nice, sometimes they have a radical. This is our exact value. Exact value. What we have to put in your calculator is just so that we can place it on the graph. So let's do -2 plus radical 1/2. That's about -1.3. So we can tell that we're right here. So here's your parabola going like this. Oops, I just missed that point. And there's the other side of your parabola. And doesn't this 2 give me a vertical stretch? Isn't that stretching my parabola? So it's not as wide as it should have been? So you did all this without using your calculator. Pretty cool, right? Yes.
So you have to like do all of that after you find the y-intercept, which you can just like know if it opens up.
But you didn't know if it was coming this side of the origin or this side. This side. What if I did this? that would be wrong. If you to find this. But if I'm close enough, what if do I touch the origin? I'm very close to it. So you're right, it kind of leads us a little bit, but we need to know exactly where we're going. Exactly where we are.
So you start at the
Well, I just to see where they would fall. Yes.
So how, for the first problem, how come, take out positive 7 again that and just say that that's just the y-intercept?
We did. We found your y-intercept by doing that. But this found your x-intercept. This is your x-intercept.
So you have to thought this as like the x squared plus x plus a number, or that number is always a y.
Yes, because the two x's are coming out to 0. Right? If you put 0 in here, I can't elaborate. Yeah, you can just say 0, 0 equals y equals 7. Guys, let's stay focused on this. They're asking great questions. You should be listening. Any other questions on this?
I know it's negative instead of, no, I know it's positive.
Well, you've got two roots, a positive and a negative. So we're subtracting 2 from both sides to get x. So you've got x equal negative 2 plus, x equal negative 2 minus. You have two roots whenever you do a square root.
Oh, so
And don't we have two roots here? Yeah, and aren't they symmetric across my axis of symmetry? Okay, let me give you your homework.